the years, public awareness of environmental issues has exponentially increased, more so in air and water pollution. One topic not frequently discussed is soil pollution, in particular heavy metal contamination. Heavy metal contamination impacts the health and well-being of our communities and requires equal public awareness. This video will address how heavy metals accumulate in soil and the remediation processes to combat pollution. Soil may become contaminated by heavy metal accumulation through mine waste, disposal of leaded gasoline and paints, as well as fertilizers, animal manures, sewage sludge, coal combustion residues, or spillage of petrochemicals, to name a few. Heavy metals are inorganic chemical hazards that can be toxic to humans and ecosystems utilizing contaminated soils. Heavy metals pose significant risk because they are held tightly on very fine surfaces like fine clay or organic matter particles. Therefore, upon introduction of heavy metals, they tend to accumulate on the upper soil layer. Very fine soil particles are more easily deposited on clothing and shoes, which can be transferred into soil dust within homes. Heavy metals within the soil particles are therefore brought into homes and can be ingested by children more readily. A simple mass balance of potential sources of heavy metal contamination include apparent material, such as industrial spills, atmospheric deposition like air pollution, fertilizer sources, agrochemical sources like pesticides, or other sources like lead paint or metal mining. Crop removal or volatilization will remove metals from soil. The mass balance is complete. To narrow the view of heavy metal contamination in soil, we will focus on one of the most common heavy metal contaminants, lead. Lead is usually of the form Pb2+, and lead solubility and binding strength to soil particulates change with pH. Similar to water and carbonate, soils are made up of sands, silts, clays, and organic matter. These soil particles have a net negative charge, and as a result will bind more favorably to heavy metals like lead. However, under lower pH or higher H+ concentrated soil, these negative soil sites will have a higher affinity for H+ ions with more concentrated charge. Therefore, the binding strength of heavy metal ions like lead is significantly impacted by the pH of the soil. Under high pH conditions, heavy metals are able to readily attach to soil particle sites. Since most soils are under alkaline environments, heavy metals tend to bind to soil particulates. To remove or detoxify heavy metals requires remediation. The goals of remediation are to increase the barring strength of the chemicals within the soil, to eliminate free liquids, and to prevent leaching into groundwater. We will cover two strategies: stabilization and phytoremediation. In stabilization, a binding agent is added to the soil to contain the metal in a solid matrix and chemically stabilize the constituents. The most readily used method is through the precipitation of high-affinity hydroxides. Hydroxides increase the pH of the soil by removing H+ ions occupying negatively charged soil sites, allowing free lead particulates to bind to the negatively charged soil. This eliminates free liquid lead from leaching into groundwater or being absorbed by plants. Phytoremediation, also called green remediation, is also an in situ process where metal accumulating vegetation is introduced to remove heavy metals. Phytoremediation is prominent technology that is environmentally friendly, less invasive, and allows for complete removal of contaminants. Vegetation with long and radial growing roots are chosen, as well as their high affinity for the heavy metal of interest. In conclusion, soil contamination is a growing concern for the health of communities as well as ecosystems. Employing innovative chemical engineering strategies can help prevent heavy metal poisoning and improve the safety of our communities. Thank you for watching.